Assalamualaikum warahmatullahi wabarakatuh and a very good afternoon. It's 4 p.m. in Malaysia and 10 o'clock in the morning in Pisa. On behalf of UTM Engineering, I would like to welcome all of our viewers to Distinguished Lecture Series number 45. My name is Nur Hazilan. I am the Assistant Dean of Continuing and Transnational Education from Faculty of Engineering, University of Technology Malaysia. And today we are very grateful to have a prominent speaker from Italy, Prof. Diego Presti, and he's going to talk on the behavior of a Pisa Tower during and after stabilization works. And I believe many of our viewers are familiar with the Leaning Tower of Pisa. So this is a campanile of freestanding bell tower, famous because of the gravity-defying 5-degree angles of lean. And technically, this leaning tower is very lucky and didn't end up as a pile of rubble because of the 5-degree angle of lean, the tilt. Okay, so today's session will be presented by Prof. Diego, and me and Prof. Diego, we met back in 2018. We were attending the first general meeting of Tuning Asia Southeast Project, a project by Erasmus Plus, led by Doisto University. And ever since, we and our colleagues from ASEAN countries have been working together to develop a framework of civil engineering curriculum design based on tuning method. Okay, so before we start the session, I would like to invite the Dean of Faculty of Engineering, Professor Dr. Rafiq, to introduce Prof. Diego. Over to you, Prof.
Thank you, Prof. Hazilan, for chairing the session. Assalamualaikum warahmatullahi wabarakatuh. Welcome, everyone, to our 45th UTM Engineering Distinguished Lecture Series. My name is Muhammad Rafiq, and I am the Dean of Engineering, University Technology Malaysia. Today, it is my utmost pleasure to welcome Professor Diego Presti from the University of Pisa, Italy. A bit about our distinguished speaker today. Professor Diego Presti was born in Palermo, Italy in 1951. He graduated with an MSc in Civil Engineering in 1975 at the Politecnico di Torino and Ph.D. in Geotechnical Engineering in 1987 from the same university. He is now a Professor of Geotechnical Engineering at the University of Pisa since November 2004. He has been the author or co-author of more than 200 publications, which mainly deal with the development of new lab equipments, testing methodologies, in situ soil characterization and soil dynamics, and earthquake engineering. Since 2011, he is a member of the Committee for the Guidelines for Seismic Microzonation, established by the Italian Prime Minister. He is the past president and vice president of the European Civil Engineering Education and Training Association, EuCEET. So that is a brief biography of our speaker today. Here now is Professor Diego Presti from the University of Pisa, Italy, to talk about the behavior of the Pisa Tower during and after stabilization works. Professor Diego Presti, over to you.
Thank you very much. I would like to thank the Dean, all the friends and colleagues of UTM for this opportunity of sharing my knowledge concerning the stabilization of the Leaning Tower of Pisa. In 1991, the Italian Prime Minister appointed an international multidisciplinary committee for the safeguard of the Leaning Tower because of evident risk of overturning. I had the privilege of cooperating with this committee, and today I will give you information on the construction detail, history of construction and the tower movement, the subsoil condition, restoration works, and I will end with some closing remarks. The Leaning Tower is located in Piazza dei Miracoli, that is Miracles Square, together with another three monuments, the Cathedral, the Baptist, and the Monumental Cemetery that unfortunately is not shown in this picture. The tower construction started in 1173 and took about 200 years because of two very long interruptions. The reasons for this interruption are not known. Anyway, the tower is essentially a hollow cylinder surrounded by 6 loggias with the columns and vault from the base up to the bell chamber. It's split into 8 segments called orders. The external facing consists of cut stones of different quality, and the annulus between the facing is filled with rubble and mortar. Unfortunately, during a visual inspection by means of a micro camera, large voids have been found in the infilling. The instrumental monitoring of the tower rotation started only in 1911. So before that date, the history of tower rotation has been reconstructed by looking at its banana shape, the shape of the tower axis, which testifies the attempts of masons, the attempts to correct the progressive rotation of the tower. The last details testifying this rotation is the number of steps to reach the bell chamber, 6 in the south side and only 4 in the north side. Another two essential aspects, important negative aspects concerning the history of the tower is the walkway excavation done by the architect della Gherardesca in 1838. This walkway is called the Catino, and the good intention was to show the tower in its original shape. Indeed, the tower sank into the soil because of the settlement. But unfortunately, as the water table is just 1 meter below the ground table, after excavating, there was a water inflow, and it was necessary to realize the permeabilization work. All this activity, as we can see later, caused a very dangerous tower movement. As the structural aspect, the critical point is here, at the end of the first cornice. Indeed, there is a staircase constructed inside the annulus from the base up to the 6th cornice. And the presence of this staircase reduces the cross section at this level. You have here an idea of the infill and the facing, but especially of the stress distribution around this opening. And you can see the very high value that have been measured by flapjack and the external and internal facing, which are 10 times the stress in the infilling. This is because of this, the presence of this staircase. So the risk, the committee considered the possible risk of a terrible collapse because of this problem. And as a counter, a number 3 steel cable were put at that level for pre-stressing the structure. As I told you, the movements of the tower have been reconstructed thanks to the shape of the tower axis. Here, the bell chamber was completed. And you can see that initially the tower was leaning towards north of 0.2 degree. Then we have other documents, fresco and written documents that give us information about the evolution of the rotation. The first measurement by plumb line was done by Crazy and Taylor in 1817. And after the excavation of the walkway around the tower, another 40 years later, another measurements with the same methodology was done by Raoul de Fleury. And this difference is about half a degree because of this negative effect of this excavation. Then instrumental monitoring started, and at this point in 1993, the rotation was about 5.5 degrees. So the main problem, apart from the structural problem we already have seen, was the increase of the rate of tilting and the high entity of the tilting. This is essentially a problem of soil structure interaction because the structure is very slender and very heavy, and the top on is seated on a very compressible ground. The simplest model for this structure is given by an inverted pendulum with the mass concentrated at the top and the reaction spring at the base. We can model the spring as a foundation of a given diameter resting on an elastic half space with a given characteristic of Young modulus and Poisson ratio. Rotation and settlement can be linked with this elastic simple model to the weight and the resisting moment, which of course depend on the rotation stiffness and on the stiffness. On the other hand, the overturning moment is given by the byproduct of the weight by the height of mass concentration and the sin of alpha, the rotation. The safety factor can be expressed by the ratio of the resisting moment to the overturning moment. With this simple moment, all the information available, the committee defined a value of 1.1, so very close to a neutral condition, which is immediately before the collapse. The subsoil of Pisa consists of three horizons: Horizon A, Horizon B, and Horizon C. The first one deposited in a deltaic environment mainly consists of a silt mixture with a sand layer at the base. This deformation of the layer represents exactly the average settlement of the tower. Then we have a marine formation mainly consisting of clays with an intermediate sand layer. The upper clay is very soft and compressible. The intermediate is a stiff clay. The lower clay is a normally consolidated clay. The lower sand is a very stiff layer extended 400 meters. And from this test, cone penetration test carried out all around the tower, you can see that the sand layer disappeared, the upper sand layer disappeared in the south side. And this could explain why the tower, after an initial rotation towards north, started to rotate towards south. The hydraulic conditions are also very complex because we have three aquifers and we have three different piezometric heads with oscillation. This is also a negative factor, but there is not enough time to enter in detail. So the main threats to the tower integrity have already been discussed. The progressive increase of rotation and the rotation rate, and the risk of sudden masonry failure on the south side between first and second cornice. As a countermeasure, a first temporary countermeasure, full reversible, was to add a weight of 600 kilonewton on the north edge of plinth. The final intervention consisted of under excavation on north side, so ground extraction to produce a back rotation of the tower. Before starting with the extraction, numerical analysis, large-scale physical model, and a first reduced attempts have been carried out. You can see here the lead ingot for the temporary stabilization and its effects. In 1993, beginning the counterweight application. As a further measure of safety during under excavation, a cable stay structure was realized. 2 anchor blocks and these cables to apply a force to the tower in case of a problem during under excavation. You can see here the cables and the cable stays. The under excavation, final under excavation, was carried out with this battery of augers, extended just beneath the north basement, not extending beyond because it would be negative as a result of numerical and experimental analysis. And you can see here the battery of augers and the effect of under excavation. The east-west plane remained stable. The north-south plane showed this rotation towards north. This is the preliminary under excavation. This is the full under excavation. And this has continued with a very small increase and is monitored right now. My colleague Nunziante Squeglia is in charge of the continuous monitoring of the tower. As for the settlement, the south registered 1 centimeter eve, and the north a settlement of about 16 centimeters. And then I will end my presentation with some final consideration. First, you can see here direct check of the effect of intervention before and after. And in this scale, you see the effect of intervention. We are back in the past. We are at the same rotation before the excavation of Catino. And you can see here the pictures of the 3 geotechnical people who took part to this international committee. And final consideration, in the 70s, an engineer from Rome, Mr. Terracina, published a paper on geotechnique suggesting the under excavation as a possible stabilization measure. It was long criticized by the Italian academia and not only. And the only person who appreciated his suggestion was Professor Carlo Terzaghi, the founder of geotechnical engineering. So sometimes academicians are very, very supponent. But that is the case of these people. In particular, Professor Yamiolkowski received a card from a young girl, 9 years old, from Bangladesh, saying there are many unemployed people in Bangladesh. Why don't you ask them to excavate under the tower for a back movement to the tower? And I am pleased to conclude with this imaging, saying, thank you, Chumti Baba. Thank you very much, everybody, for your patience.
Okay. So thank you, Prof. Diego. How do you feel now?
Yes.
Yeah. To all our viewers, for your information, Prof. Diego was supposed to deliver his presentation 2 weeks ago, but then we had to cancel the session and postpone to 2 days due to some technical problem related to internet connection. But luckily, we have another chance to have Prof. Diego. So thank you so much again for such an insightful presentation on the Tower of Pisa. Everybody are so interested on this structure, the campanile, the freestanding bell tower. Everybody wants to go to Italy just to see how this structure can still, stand still, not just survive the leaning of almost 5 degrees, but also it did survive the earthquake. Am I right, Prof. Diego? It did
Yes.
survive. So
Yes.
so what's the secret of the, even though it's leaning, but it still managed to survive the earthquake? What's the secret from the structural engineering perspective, or even the geotechnical engineering perspective?
I am not sure to have well understood your question.
Yeah.
You are asking about the secret.
Yeah. How the structure can survive the earthquake, since it's leaning from year to year, it still managed. Yeah.
Survive to earthquake.
The earthquake, is it? Yeah, based
Yeah.
on my reading. Yeah.
Yeah. So seismicity in this area is not very high.
Okay.
So the maximum peak ground acceleration is less than, depends on the return period, but considering a return period of 475 years, the maximum peak ground acceleration is something as 0.1 g or less.
Okay.
But as the upper layers are so soft, we have published a paper showing that a very soft layer with a low resistance cannot transmit the waves because the stress level exceeds the stress resistance. So in reality, at the top of the deposits, we do not expect any big amplification with respect to the rock movements.
Okay. May I ask, what is the maximum degree of leaning of this tower before restoration? What's the maximum? Is it beyond 5 degrees?
5.5 degrees. Yeah.
5.5 degree.
Yeah.
Okay. So what is the current degree of the tilt, the leaning?
5.
5 degree after the restoration.
Yes.
And what do you think? How long the structure can survive from this the leaning? It's not easy to answer, but what do you think? Can it survive? Yeah.
So there are two, one optimistic and one pessimistic prediction for the future.
Okay.
The pessimistic say that this back rotation will vanish, and then the tower will start to rotate towards south and will reach the same rate as before.
Okay.
The optimistic say no. The movements of rotation towards north will end, and the tower remain in the fixed position. In any case, all the facilities are here.
Okay.
So in the future, if the opera primaziale, which is in charge of taking care of the tower, can repeat the under excavation and recover again the critical rotation that could happen.
Okay. So from my understanding, this structure was built in the uh, 12th century, is it? And then
Yeah,
it took around 200 years to be completed. So
yeah,
yeah,
because
so
there were two very long periods of
yeah,
interaction.
okay. So means
Because
that
of lack of money, wars,
okay,
I don't know. Nobody
okay.
knows.
I can't imagine 200 years just to build a campanile, a freestanding bell tower. Amazing. But what is more amazing is the structure is still here, still stand still,
Yeah.
can survive. Okay. So do we have any question from the viewers? If you to our viewers, if you have any question, you can drop your question in the chatting room column on your right side of your screen, and then our technical crew will pick up your question for Prof Diego. So we just wait. Is there any question? I have asked 3 questions to Prof Diego. The last time we met, back in last year, I think, prior to COVID-19.
Yes,
The
was
last,
in
yes,
Vietnam. Is
uh,
it correct?
I think in Bangkok. That the final
Yeah,
meeting of ASE.
yes,
Yeah,
yes, you're
yeah.
right.
Because we had two meetings in Bangkok. The last meeting, the final meeting, was supposed to be held in Europe, I think in Belgium, but
Yeah.
somehow they, due to some reason, they have to change to Bangkok. But it's okay. Okay, we have one question from Shazwan Shah. What is the increment of leaning angle annually, the rate of leaning? And did the government of Italy take any precaution step engineering related to maintain or procure the Pisa leaning tower? Yeah, he was asking about the actual rate of leaning. Yeah, per year.
Uh,
Yeah.
okay, so the measure is to maintain a monitoring of the with the several types of instrumentation to take under control the movement of the tower. So right now the movements are very small, uh,
Okay.
continue to be towards the north, sense of arcs per year, very small.
Yeah, that's very small. And is there any specific precaution step engine related to maintain or procure the Pisa leaning tower? Means that after the stabilization works, what else? Do we just need to wait for another report on the problems when it start to occur, or the Italian government has a plan for future plan for uh, long term plan to recover the reliability of the Pisa tower?
Uh, no, the Pisa Tower is considered safe.
Okay,
Uh,
okay,
as considered safe. Tourists can enter the tower now. Of course, with COVID, the number of visitors has been reduced
okay, okay,
and so on. But tower can be visited. We consider the tower safe and good health right
okay,
now because this small rotation continues to be toward the north, not
okay,
south.
okay,
As it continues to rotate back, but the
okay.
quantity is very small.
All right, okay. Okay, any more question from our viewers? Okay, if there is no more question, so I would like to thank Prof. Diego again for your willingness to spend your time and sharing your thought on this matter. I think it's so valuable to our viewers because it's not every day we can listen to the presentation from the expert, especially from the Italy. So thank you again, Prof. Diego. I do hope we can meet again in the future. And we pray for the end of the COVID-19 pandemic. And to close the session, I would like to again to invite our dean, Professor Dr. Rafiq, to close the session. Okay. Oh, according to our dean has another meeting. He need to attend another meetings after during this session. So therefore I will close the session. So to all our viewers, thank you again
Thank
for
you.
joining our distinguished lecture series. Thanks again to Prof. Diego Presti. Hopefully, this will be the beginning of fruitful collaboration between your
I hope so.
university and UTM, not just uh, for the Erasmus Plus project, but also other project. And to our viewers, for your information, Prof. Diego is going to retire next year. He's 70, but he still looks, you see, 70, but he looks younger than that.
Thank you so
Trust me.
much.
So, thank you again, Prof. Diego. And to our viewers, don't forget to like our Facebook, and you can follow the recorded session. The recorded session will be uploaded onto our Facebook and also our YouTube channel. Okay, so thank you and bye-bye.
Thank you. Bye-bye.
Okay, bye.
Bye-bye. Thank you so much. It was a pleasure.
See you again, Prof. Diego.
See you. See you.
Okay, thank you, Prof. Diego. Bye-bye.
Bye-bye.